Welcome. This video will examine the steps to discover the molecular weight of a compound element. Finding the molecular weight of compound elements helps chemists to discover many important things. Let's dive right in. To show you an example, we'll begin with finding the molecular weight of ammonia. The first step in finding the molecular weight is to know which compound you're investigating. The first example is asking for the molecular weight of ammonia, and the molecular formula is NH3. In step 2, refer to the periodic table of chemical elements to find the molecular weight for each individual element from the given compound of NH3. The elements for ammonia are nitrogen and hydrogen. Upon looking at the periodic table, one can see that hydrogen has a molecular weight of 1 gram per mole, and nitrogen 14 grams per mole. In step 3, find how much of each element is in the chemical formula. To do this, take each element and multiply the molecular formula for that element by the number of atoms, located via the subscript found in the chemical formula. If there's no subscript, it means there's only one element atom. If there is a subscript, it reveals the number of atoms for that particular element. Looking at ammonia's chemical formula of NH3, nitrogen has no subscript, therefore only one atom of nitrogen is present in the compound. Because hydrogen has a subscript of 3, it means that there are 3 hydrogen atoms in the compound. Because hydrogen has a subscript of 3, it means that there are 3 hydrogen atoms in the compound. Since nitrogen only has one molecule, multiply the molecular weight, MW, by 1 for 1 times 14, or 14 grams per mole. Next, hydrogen has 3 molecules, so one would multiply its molecular weight, MW, by 3. Now that each individual element's weight in the compound is known, the final step will provide the molecular weight. With each individual element weight known, now find the molecular weight of the compound ammonia. This is done by taking the individual weight of each element in the formula and adding them together. Thus, nitrogen is 14 and hydrogen is 3. So add 14 and 3 for a total of 17 grams per mole. In this next example, find out the molecular weight of a more complicated compound, iron nitrate. In the first step, find the molecular formula of iron nitrate, which is FeN03, 2. Next, move on to step 2. Our formula is FeN03, 2 for iron nitrate. In this step, we'll get the individual elements' molecular weights. The elements in the formula are Fe for iron, N for nitrogen, and O for oxygen. Iron's MW is 55.845 grams per mole. Nitrogen's is 14 grams per mole, and oxygen is 16 grams per mole. Let's move on to step 3. In step 3, we look at the chemical formula and we see how many of each element is there. Once we have this, we'll multiply the number of each element we have by that element's molecular weight. There's only one iron, or Fe, so we would multiply that by 55.845 grams per mole, and that gives us 55.845 grams per mole. When we look at the formula, it shows that there are 2 nitrogens, so we would multiply the 2 by the molecular weight of nitrogen, which is 14 grams per mole, and that gives us 28 grams per mole. The last element to look at is oxygen. Here we have 6 oxygen, so we would take that 6 and multiply that by the molecular weight, which is 16 grams per mole. That gives us a total of 96 grams per mole. Now, we go on to the final step. In step 4, we'll take all the individual weights we found in step 3 for each element and add them together. For iron, we got 55.845 grams per mole. Nitrogen, we got 28 grams per mole. And oxygen, we got 96 grams per mole. Take these numbers, add them together to get the compound's molecular weight. When added together, the molecular weight comes to a total of 179.845 grams per mole. Thanks for watching, and have a great day.